This is section 5.2 on sum and difference formulas. Now, what we've talked about so far is proving trig identities, and what we're going to do with this lesson is we're going to move into being able to solve more difficult problems by reducing things that we have into compact pieces and knowing some formulas that are going to help us break up these harder problems into easier ones. Okay, so let's go. First of all, we're going to see is sine of A plus B equal to sine A plus sine B. How are we going to do this? Here's what we're going to look at. We are going to look at sine of 60 degrees plus 30 degrees, and we are going to ask, is this equal to sine of 90 degrees? Sorry. Sine of 60 degrees plus sine of 30 degrees. Because really this is just putting in values for A and B that we can actually find values for. So let's look. If we have the sine of 90, which is what 60 plus 30 is, we're asking, is this equal to the sine of 60 plus the sine of 30? Well, the sine of 90, if we use our unit circle, we find out that this is equal to 1. And the sine of 60, so I'm putting this question mark up here to see, because I'm asking, is it possible? Is it equal? So if I use my unit circle to find the sine of 60, I find out that the sine of 60 is 1/2. And I find out that the sine of 30 is 1/2. The sine of 60 is square root of 3 over 2. Well, what that gives me is 1 is equal to 1 plus square root of 3 over 2. Well, I know that this would have to be 1/2 in order for this to be 1. I know that it's not 1/2. So this is not equal. What does that tell me? It tells me that this is not a way to reduce. Or they are not equivalent. So what is the formula for the angle addition? Well, if I look at this example down here, cosine of A plus B, the cosine of A plus B is actually going to be cosine of A times cosine of B minus sine of A times sine of B. This is going to be my formula that I use to expand these things. And so when I move down to example 1, what I'm going to do is I'm going to use this formula to solve this problem. Instead of thinking about 75, which I don't have on my unit circle, I'm going to try to break 75 up into cosine of 45 plus 30. Because 45 and 30 are values that we know have values on the unit circle. And so if I'm doing cosine of 45 plus the cosine of 30, I'm going to expand it to this. The cosine of 75 is equal to the cosine of 45 plus 30, which is equal to cosine of 45 times the cosine of 30 minus sine of 45 times sine of 30. Okay? When I look to my unit circle, I can use these values, remembering of course that cosine comes first, then sine. So this is going to be square root of 2 over 2 times square root of 3 over 2 minus square root of 2 over 2 times 1/2. Let's reduce these fractions. Well, I know that square root of 2 times square root of 3 would be square root of 6 over 2 minus square root of 2 over 2. So what I can do is I can keep my denominators here, because remember this is 2 times 2, this is a multiplication sign. So I'm going to have a common denominator of 4, and I'm going to have square root of 6 minus square root of 2, and this is my answer. I don't need a decimal value. This is more exact, because it says exact value. This is exact because I don't have to round my square root of 6, I don't have to round my square root of 2, no rounding involved. This is good. Okay? Let's look to example 2. We're going to show that cosine of x plus 2 pi is equal to cosine x. A little typo there. So show that cosine of x plus 2x is equal to the cosine of x. Well, if we expand this into what it means, this is really going to be cosine of x times cosine of 2 pi minus sine of x times sine of 2 pi. Now, if you're out there and you're jumping up and down, it's because you see what's going on. I know this is the cosine of x, I can't reduce that, but if I look to 2 pi, I know the cosine of 2 pi is really equal to 1. And if I look to the sine of x, it stays the sine of x, but the sine of 2 pi is actually going to be equal to 0. So when I reduce, this goes away, and I'm left with the cosine of x, which is what I want it to be equal to. So that's actually a pretty slick little proof kind of thing there that looks complicated, but it's really not. Okay? What this is showing is that if I'm at value x, whatever the angle happens to be, and I go all the way back around, so I go all the way around my unit circle, right? Here's my unit circle. Okay? If I'm at an angle here, and I go all the way around, the cosine is going to be the same, right? Because 2 pi is really all the way around, so the cosine is going to be the same. So the cosine of this angle here and its coterminal angle when I go all the way around is the same. In example 3, we're going to go the opposite way. We're going to write this as a single cosine. If we look closely, we can see that this resembles the formula. I have cosine of something times cosine of something else minus sine of something times that sine of something else. And so because it leads with cosine, I know that I'm going to have two things. One of them is going to be 3x, and one of them is going to be 2x, because 3x and 2x. So really this is going to be the cosine of 5x. Okay? Pretty simple that way. A couple of other formulas. We've already discussed cosine of a plus b. Let me rehash those for you. Cosine of a times cosine of b minus sine of a times sine of b. So then if I go to the subtraction, the difference formula, I'm going to have cosine of a times cosine of b plus sine of a times sine of b. Okay, so pretty simple as far as that is concerned. Let's use this formula to solve this next one. I'll leave it up here like this. Cosine of 90 minus a is equal to the sine of a. Let's remember, 90 minus a is a cofunction with sine of a, meaning that this should be true. Because if this is true, then everything that we've already talked about is true. So let's look at what happens. If I use this difference formula, I've got cosine of 90 minus a is equal to the cosine of 90 times the cosine of a plus the sine of 90 times the sine of a. When I go ahead and reduce here, what I end up with is the cosine of 90 is 0. So it's pretty convenient how that works out. And the sine of 90 is 1. And so just like in our other proof, this cancels out, and I'm left with sine of a. And this makes sense because 90 minus a and a they're complementary. And we know that they're complementary because that's the definition of complementary. The difference between an angle and 90 is the complement. And so because we're taking the cosine of the complement, that's equal to the sine of the actual angle itself. This makes sense. All right? Last two formulas, and then we're done. So what is it for sine of A plus B? The sine of A plus B is a little bit different. It's going to be the sine of A times the cosine of B plus cosine of A sine of B. So then the sine of A minus B is going to be sine of A times cosine of B minus cosine of A times sine of B. Note the differences. Make sure you know what's going on. That was part one. We'll be coming at you with part two next time. Thanks for watching, guys.